The solar system is often shown as a neat, flat diagram, a straight line of planets, evenly spaced, quietly orbiting the sun like marbles on a table. But that picture hides something far stranger, because the solar system isn't just flat, it has depth, it has layers, and once you start asking what exists above and below the plane of the planets, the story becomes much bigger than orbits and distances. The reason the planets appear aligned is not coincidence. They formed from a spinning cloud of gas and dust billions of years ago. As that cloud collapsed, it flattened into a rotating disk, and the planets inherited that motion. That disk still exists today as the reference plane of the solar system. Most planets follow it closely, but not perfectly. Mercury's orbit is tilted by about 7 degrees. Pluto's orbit is tilted by more than 17 degrees. And comets? Many comets ignore the plane entirely. They arrive from steep angles, slicing through the solar system as if the planetary disk were a record and the comet were a needle. So if the planets mostly stay in one flat sheet, a simple question follows. What exists above it, and what exists below it? To answer that, we have to drop one assumption first. In space, there is no universal up or down. On Earth, gravity gives us direction. Down is toward the planet, up is away from it. But in space, orientation depends entirely on perspective. Two astronauts floating near each other can be upside down relative to one another, and neither is wrong. So when we talk about above or below the solar system, we're not describing absolute direction. We're describing direction relative to the plane of planetary orbits. Once we accept that reference, we can start exploring what surrounds us vertically. And the first structure we encounter is one of the most mysterious things in astronomy. A structure we have never seen directly, but one that may surround the solar system in every direction. Far beyond the planets, beyond Neptune, beyond the Kuiper Belt, astronomers believe there exists a vast spherical cloud of icy objects. This is known as the Oort Cloud. Unlike the planetary disk, the Oort Cloud is not flat. It is thought to be a gigantic shell wrapping around the solar system like an invisible sphere. It may contain trillions of frozen bodies made of water ice, ammonia, and methane. These objects are leftovers from the early days of planetary formation. When the solar system was young, the giant planets, especially Jupiter and Saturn, gravitationally scattered enormous numbers of icy fragments outward. Some were ejected entirely. Others were flung into extremely distant orbits where the gravitational influence of passing stars and the Milky Way itself slowly reshaped their paths. Over time, those scattered orbits formed a spherical distribution. That shape explains something important. Long-period comets don't come from a single direction. They arrive from above the planetary plane, below it, and from every angle in between. Their trajectories suggest a distant spherical source. The Oort Cloud fits that pattern. It may extend tens of thousands of times farther from the Sun than Earth does, possibly reaching distances comparable to a light year. That means the solar system is surrounded by a vast, unseen halo of potential comets. But even that isn't the true edge of the Sun's influence, because the Sun doesn't just control gravity, it also controls space itself. The Sun constantly emits a stream of charged particles called the solar wind. This wind flows outward in all directions, carrying the Sun's magnetic field with it. Together, they inflate a massive bubble around the solar system. This bubble is called the heliosphere. Inside it, solar particles dominate. Outside it, interstellar space takes over. The boundary between these regions is known as the heliopause. And this boundary is real. Human-made spacecraft have crossed it. The heliosphere isn't a perfect sphere. Because the solar system is moving through the galaxy, the bubble becomes compressed in the direction of motion and stretched behind it, like the wake of a ship traveling through water. So above and below the planetary plane, the Sun's magnetic influence still extends far into space. But beyond that boundary, we enter something even stranger, interstellar space. And even there, we are not alone. The solar system is currently traveling through a region called the Local Interstellar Cloud. It's a faint, wispy collection of gas and dust, not dense like a nebula, not empty like a vacuum, just enough material to interact with the heliosphere as we move. And we are moving fast. The Sun orbits the center of the Milky Way at roughly 800,000 kilometers per hour. As it does, the solar system drifts through different interstellar environments, some denser, some thinner, which leads to one of the most surprising discoveries about our cosmic neighborhood. We're inside a bubble, a giant low-density cavity in the galaxy known as the local bubble. This region is unusually empty compared to surrounding space. Astronomers believe it was carved out by multiple supernova explosions millions of years ago. Those explosions swept away gas and dust, leaving behind a vast cavity. The solar system just happens to be passing through it. The local bubble is not perfectly spherical. It has edges, walls where gas and dust pile up, and those dense walls can become regions where new stars form. Destruction creates structure, explosions shape environments, and empty space turns out to be anything but empty. If we zoom out even more, we discover that this vertical layering doesn't stop with the solar system. The Milky Way itself has an above and a below. The galaxy is not a perfectly flat disk. It has a central bulge, spiral arms, and a warped outer structure. Surrounding it all is the galactic halo, a roughly spherical region containing old stars, star clusters, and enormous amounts of dark matter. Once again, up and down only exist relative to a chosen plane. Earth has one, the solar system has one, the galaxy has one. Each layer sits inside a larger layer, and the solar system is just one moving structure inside a vast vertical architecture shaped by gravity, motion, and time. So the next time you picture the solar system, don't imagine a flat diagram on a classroom wall. Imagine a ship, sailing through invisible seas, surrounded by layers of ice, magnetic fields, drifting clouds, and ancient blast-carved voids. We are not just orbiting the Sun. We are traveling through a galaxy filled with structure in every direction. And somehow, inside all of that complexity, life emerged on a small blue world. That fact alone makes our place in the universe extraordinary. Before you go, quick question. If you could instantly teleport to just one layer above our solar system, which would you choose? The Oort Cloud, the heliosphere's edge, or the local bubble we're drifting through right now? And what do you think would feel the most mind-blowing to actually see with your own eyes? Drop your answer in the comments, one pick and one reason. And if you want to explore what humanity might become beyond Earth, beyond tomorrow, beyond 2200, subscribe.